Hello. So this is now an improved version of the explanation of the low energy stopping power dependence on velocity. I realized that the first explanation was maybe a slightly messy, so I changed the slides and tried to explain it better here. So the point is to try to understand why the electronic stopping at low velocities below the Fermi velocity of an ion would be proportional to the velocity of the ion. And this is an explanation which was originally provided by Fermi and Teller in the reference given down here. And most of the text here are direct quotes from the paper. So what we consider is an ion. This illustrates the nucleus, and this is the electrons of the ion, which is moving in a free electron gas. As we know, metals, the free electrons can be considered a Fermi gas. And when it moves, of course, the electrons in the ion will collide with the electrons, which are, of course, present everywhere in the solid. It's clear, since the electron in the ion and the electron in the solid, they have the same mass. So if there is a head-on collision, the electron in the ion would lose all its energy to the electron in the solid, and this electron in the solid would get the velocity v, which would be exactly the same as the velocity of the ion. And this from this example, this Fermi-Teller explanation starts. So they say that if you have an electron-electron collision, it will transfer its momentum to the electron in the solid. But the crucial idea comes if you look at the one-dimensional density of states of electrons in a degenerate Fermi gas. And as you know from solid-state physics, also at regular temperatures like room temperature, the distribution of electronic states in a solid is very, very close to this 0 Kelvin Fermi gas. And the Fermi-Teller argument is that if you have electrons in the solid which gain the velocity v, they can contribute to the stopping only if they are close to the Fermi energy. Because if you have an electron here, it can jump out above the Fermi velocity where there are unoccupied electron states. Whereas if you have electrons below this Vf minus V, then this electron, it cannot possibly jump here because all of these states are occupied, and there is no free hole where this electron could be, so this kind of a transition is forbidden. And this is the key point. So this says that this red area in this picture, that's the those are the electrons which can be excited above the Fermi level, and it is clear that the number of electrons here is proportional to the velocity. If the velocity becomes higher, then there are more electrons that can be excited. So, and this gives the explanation why the stopping power is proportional to velocity, because the amount of electrons that can be excited and that can slow down the ion increases with velocity. So this is actually quite simple explanation, and it turns out from many later studies that indeed the low energy stopping power is it's not exactly maybe proportional to velocity, but it's very close to being proportional to the velocity. So this was this added explanation, and now for the rest of the material, you can please go back to the previous video on this section.